Hello, College Algebra, and welcome to the 3.7 lesson on inverse of functions. But before we do that, I just want to solve this little equation right here real quick, just as a warm-up. So here we have 3x plus 2 divided by 4 is equal to 8, and we need to solve for x. First, I would recommend getting rid of this division of 4. And of course, if you're dividing by 4, to get rid of it, do the opposite operation and multiply. So then the 4s would cancel over here, which gives you 3x plus 2. And then the 8 times 4 on the other side should give you 32. And then from here, the rest is pretty easy. Here, just subtract 2 to both sides, and you'll get 3x equals 30. And then, of course, divide by 3, and you get x equals 10. Simple enough. The only hard part was getting rid of the division of 4, but once you got that, easy. And believe it or not, what we just did is very similar to what we're going to be doing today. Specifically, we'll be doing something like this to find inverses of certain functions. So let's begin. Now, some of you may remember from Algebra 2 working with inverses, but if you don't remember what an inverse is, let's look at this definition. Inverse of a relation. If R is a relation mapping elements from the domain to the range, then the inverse, which is denoted by R to the power of -1, is basically just taking your domain and range and just flipping it. So now, any words. Say you have an ordered pair with an x and a y, just flip them, and voila, you would have the inverse. Done. So say, for example, you have this relation T with these 3 ordered pairs. And what if I asked you to find the inverse? Well, it's as easy as it sounds. Take your first ordered pair, switch the values around. Which, of course, well, if you switch 1 and 1 around, you technically still get the same point. But if you do it with the other point, switch the -1 and the 1 around, this is what you would get. Your -1 is in the back, your +1 is in the front. And then your 2 and the 4 would switch. And then you'd have 4, 2, and that would be your inverse. Pause for a moment, my phone is going off. Okay, phone is off. Continue. But as I was saying, inverses, really easy. You just take the point, switch the values, and you're done. One extra thing you'll have to do is you'll have to state the domain and range of your new set. So in other words, take a look at your new inverse set, say, okay, my domain are these values, 1, 1, and 4. But of course, you don't need to write the 1 twice, so the domain would actually just be 1, 4. And then your range of your new set of ordered pairs will be 1, -1, and 2. But it's as easy as that. Switch your ordered pairs, and that's your inverse. Then just state your new domain and your new range. Done. Let's try that one more time on the next slide. So we're given these 4 ordered pairs. Our first step, let's find the inverse. Just take every one of these points, switch them around. So for the first one, you'd have -10, 10. Switch the other 2 around, you get -7, 2. Next one, when you switch, you get -8, 3. And then lastly, you switch the last pair around, you get -9, 4. And that's it. Easy peasy lemon squeezy. And then for step 2, you'd have to list your new domain, your new range. So these would be your domain values, -10, -7, -8, and 9. And no, you do not have to list them from least to greatest. You can label them just as I did up on the board. And then, of course, your range values will be 10, -2, 3, and -4. And just like that, you got 2 points on your Hawks homework. Done. Easy peasy. Now, if only all the problems for finding inverses were as easy as that, sometimes you're not given the ordered pairs. Sometimes you're given an equation. Like say you're given 2x minus 7, and it wants you to find the inverse equation. And that's what we're going to be doing next. And there is a 3 to 4-ish step procedure on how to do it, but once you get the hang of it, it's actually really easy. So let's go through the first 3 steps, because those are the most important. The first step is you're going to take f of x and replace it with y. So over here, let's say I'll take the f of x, I'll get rid of it and replace it with y. There you go. That's step 1. Easy. Step 2 says to interchange or switch the x and y in the equation. So in other words, what that means is take your y and your x and make them switch places. So then you would have x equals 2y minus 7. And then step 3 says solve your new equation. And literally that's as easy as it sounds. Take your new equation, solve for y. So probably first you would add the 7, then you would divide the 2, and you would get x plus 7 all divided by 2 equals y. And once you get to there, the x plus 7 divided by 2 would be your final answer. Or in other words, your inverse answer. And step 4 says replace y with the inverse notation. But technically you don't have to do that because, well, Hawks already does that for you. So technically the 4th step doesn't really matter. It's the first 3 steps that matter. By first replacing the f of x with y, switching the x and y around, and then solve. And once you've solved for y, you have your answer. Piece of cake. Let's just try a couple examples so you can get the feel for the procedure, and then you guys should be good. So let's say you're given this equation, and we need to find its inverse. So just like we said on the previous slide, first thing you're going to do, you're going to replace the f of x with y. So y equals 4x minus 1 cubed. Then step 2 is you're going to take your y and your x, make them switch places. So now your x is out here on the left side, and your y is going to be here with all the other numbers and symbols. And then step 3, we got to start solving for that y and getting that y alone. And usually the way you want to start solving for y is you usually want to start from the outside and work your way in. So more specifically, this power is the farthest thing away from y, thus on the outside. So we'll start with that first. So we need to solve and get rid of this power of 3. And just a refresher, to get rid of a power, you take its root. So if you want to get rid of the 3rd power, take the 3rd root to both sides. So when you do that, we'll have the cube root of x on the left side. Then on the right side, your root and your power will be officially gone. And all you'll have left is 4y minus 1. And once you're done with that part, the rest is really easy. From here, to solve for y, go ahead and add 1 to both sides. Let's bring this over here. So now you have cube root of x, and then plus 1. Make sure the plus 1 does not go in the root, equals 4y. Then we're almost done. Just divide by the 4. So now cube root of x plus 1 all divided by 4 is equal to y. And now that your y is officially alone, congratulations. You have your inverse answer. So in other words, your inverse, f to the power of negative 1x, is equal to cube root of x plus 1 all over 4. Done. And again, you don't need to put this notation. The Hawks program will do that for you. Just type in this equation and you're done. So let's try a couple more of those. There's a couple extra stuff that you might want to know, but for the most part, that's basically it. Now let's try this example. Find the inverse of the following function. So again, start with your first step. Replace the f of x with y. So y equals 4x to the power of 1/3 minus 5. And then step 2. Step 2, take your y and your x, make them switch places. So x equals 4y to the power of 1/3 minus 5. And now, step 3, we got to start solving. Now, some of you are probably looking at that power of 1/3 and thinking, how am I going to take care of that? Well, don't worry, I will show you, but not yet. Right now, let's take care of the stuff that's easier to take care of. Like, for example, it is so much easier to take care of the plus 5 right now. Let's just go ahead and take care of that so it's out of the way. So now you have x plus 5 on the left, and then you have 4y to the 1/3 on the right. And also, while we're at it, let's go ahead and divide by 4, because we know how to do that, and that's easy. So now, all I have is x plus 5 divided by 4 on the left, and on the right, I have y to the 1 cubed. Okay, now I'm going to show you how in the world are we going to get rid of that power to the power of 1 cubed. And this is how you do it. I want you to go ahead and put both sides in parentheses. And what I want you to do is I want you to take both sides to the power of the reciprocal of 3. So, or I meant specifically the reciprocal of 1/3, which is 3 over 1. Now watch what happens when you do that. On this side of the equation, or on the left side, you'll have x plus 5 to the 4th, all to the power of 3 over 1. But technically, you don't need to do 3 over 1. That's just 3. But then on this side, you got 1/3 to the power of 3. If you multiply those two, you're just going to get y to the power of 3 over 3, which if you simplify is just 1 over 1, which is just y to the power of 1. And of course, y to the power of 1, you don't really need that 1 there. You can just write just y. Look at that. The y is officially by itself. Nice. And just like that, you have your inverse answer. Done. So in other words, anytime you have a power that's a fraction 1/3 or 1/5, multiply by its, or not multiply, take the power of its reciprocal to both sides, and it will take care of your power. We'll have some more examples like that coming up, but just wanted to show you how to do that. So, with that said, let's try another example. Now, let's find the inverse of this function. So, first thing we're going to do, again, we're going to change the f of x to y, and we're going to have 4 times the cube root of x minus 5. Now, some of you may feel a little uncomfortable about the cube root of x here, and you're wondering, how am I going to take care of that? How am I going to get rid of that cube root of x? Well, I need to ask you something real quick. Way back when, I taught you guys how to rewrite this cube root as a fraction power. Or in other words, you can rewrite this cube root as x to the power of the fraction power over root. Or in other words, if I took the cube root of x and then realized my x has a power of 1, I could rewrite this as the power of 1 all over the root of 3. So in other words, this would be the same thing as x to the 1/3. So out of curiosity, I'm just going to go ahead and write that over here. So instead of the cube root of x, I'm going to rewrite that as x to the 1/3 minus 5. So that's what I have so far. So far I have this. Now, I want you to take a look at that equation. Y equals 4x to the 1/3 minus 5. Do you have that memorized? 4x to 1/3 minus 5? Now look at the previous slide. 4x to the 1/3 minus 5. 4x to the 1/3 minus 5. Oh my gosh! It's the same as the previous slide. Or in other words, it's the same as the last slide. Oh my gosh! So in other words, finding the inverse of this equation will give you the exact same inverse from your previous slide. OMG! That was easy. So I trust that you guys know how to handle this problem. I'm not going to work it out because it was already done on the previous slide. As long as you recognize that this root can be rewritten as this, then you can just solve it like we did on the previous slide. And my job is done. All right, so that was a really nice one. And believe it or not, there'll be some other examples like that where you can just rewrite it like this and you can solve it just as it was. But for now, let's move on to some more examples. So let's find the inverse of this following function. Again, let's take it to the top, the very first step. First step, replace that f of x with y. Second step, as always, switch your x and your y around. So x is here, the y is now with the 3, and then the minus 4 and the 1/3. And now our step 3. Let's start solving. And to start off, it's usually best to start on the outside. So the 1/3, or your power 1/3 is what we'll start with. And just like we did before, let's multiply, or not multiply, let's take the power of the reciprocal to both sides. So by doing that, we'll have x to the 3/1, which technically we can just rewrite that as just x cubed. And then 1/3 to the power of 3/1, you just multiply those. And that gives you the new power of 1. Because, well, 1/3 times 3/1, that should just be 3/3, which reduces to 1. But of course, you don't really need anything to the power of 1, so you can just erase that. Don't need any more. And now, the rest is easy. For now, I can just add the 4 to both sides. So I get x cubed plus 4 equals 3y. And then just divide by 3. So then I'll have x cubed plus 4, all divided by 3, all equal to y. And now that your y is alone, congratulations, you have your inverse answer. Piece of cake. So you had more practice working with the power of 1/3. Again, you'll have a little bit more practice with that with a couple more examples. But there you go. Let's try another one. Again, find the inverse. First step, place that with a y. X cubed plus 4 to the power of 1/5 minus 2. And then second step, switch that x and y. So now my x is out here. I got y cubed here plus 4 to the 1/5 minus 2. All right. And now our third step, let's get that y alone. So again, it's usually best to start from the outside and work your way in. And the minus 2 is the farthest thing away from y. So let's take care of that first. It's pretty easy to take care of that. Go ahead and add the 2 to both sides. So then on the left, you have x plus 2. And on the right, you got y cubed plus 4 to the 1/5. Oh, something else I wanted to ask real quick. Yep. Never mind. Moving on. So now, the 1/5 is now the farthest thing away from the y cubed. So we're going to take care of that. And then what we're going to do, just like we've done before, take both sides, raise them to the power of the reciprocal, 5/1. So then we'll have over here x plus 2 to the power of 5/1, which is just 5. And then 1/5 to the power of 5/1. That will just give you a power of 1, which again, you don't need it. And from here, the rest is easy. For now, let's go ahead and subtract 4 to both sides. And I do want to mention, when you subtract that 4, make sure it stays on the outside. It does not get subtracted to the plus 2. Don't do it. And then all we have left to get the y by itself is to get rid of that power of 3. And of course, you guys know how to get rid of a power of 3. Just take the cube root of both sides. Now I do want to mention, when you take the cube root, make sure it goes over everything, including the minus 4. So then for your final answer, which I'll write over here, cube root of everything, the x plus 2 minus 5, or power of 5, minus 4, all equal to y when everything cancels. And again, once the y is by itself, you have your inverse answer. Now I'm trying to remember, I think there's something I forgot. Let me go back. Oh, yep, it was right here. I do want to mention, for this answer, make sure that the entire fraction or the whole fraction is in parentheses. Because if you rewrite it where the parentheses is just around the top, or in other words, if you type it in like this, the Hawks program will count it wrong. You have to make sure this entire thing is in parentheses, the entire fraction. And that was just for that example. I forgot to mention that before. I'm sorry I didn't say it earlier, but at least I'm saying it now. So, Hopefully you got that down. Now let's go back. We already did that one. We already did that one. Yes? Yes, we did do that one. We just finished that one. And now this one. Well, to start off, well, I don't know about you, but that fifth root is kind of throwing me off. Now I wonder, could I use that same trick where I can do power over root? And the answer is, yes, you can. Or in other words, think of it this way. The fifth root of this entire thing, well, x cubed plus 4, that technically has a power of 1. So technically, I could still use the power over root rule. X cubed plus 4, all raised to the power of 1 divided by the root of 5. So I wonder if I could rewrite this as this in my equation. So gx equals, let's try replacing this with x cubed plus 4 to the power of 1/5, and then all minus 2. All right, now check it out. Take a look at that equation, then take a look at the previous equation. X cubed plus 4 to the power 1/5 minus 2. X cubed plus 4 to the power 1/5 minus 2. Oh my goodness, it's the same as the last slide. Just going to go ahead and write that down. Oh my gosh, it's the same as the last slide. Yep. So in other words, you guys know how to solve this one from here. You just did it on the previous slide, which means it's going to have the same answer. As long as you recognize that you can rewrite this fifth root as this, and then just go from there. Piece of cake. All right, I think we're almost done. Got a few more examples. They should be pretty quick. So now this example, this one's going to be a little bit more challenging, but it won't be too bad. But let's go ahead and start. First thing, replace my function notation with y. And then, second step, as always, let's replace that y with the x. Make them flip-flop. So x equals 2, all divided by 3y minus 2. And this is where things get a little hairy. Now, some of you are probably looking at this 3y minus 2, and you're like, I don't like the fact that y is in the bottom of a fraction. Oh no, why, Miss Schulen, why? No. Okay, I'm done. Now, if you're thinking that, there is a way to rewrite this so that the y is not on the bottom of the fraction. Think of it as the 3y minus 2 is being divided. And of course, maybe to help us rewrite it, think of it as, instead of dividing, what if we multiplied 3y minus 2 to both sides? So then on the right side, I'd be taking 3y minus 2, multiplying it by this x. But then on the right side, you'd have 3y minus 2 top and bottom, which would mean they would cancel. They would cancel, and all you have left is that 2 on top. Hooray, no more fractions! Okay, I'm done being silly for now. Continue. But yes, no more fractions, which will make our lives a lot easier. So now, to start getting the y alone, to make things easier, I would actually recommend you distribute that x. to 3y minus 2. So then you would get 3y times x when you distribute, and then minus 2x, all equal to 2. And now, let's take some further steps to solve. I'd say adding the 2x to both sides would probably be an easy thing to do, so we can do that. And now we have 3yx on the left, and on the right we have 2 plus 2x. Okay, so now what we have to do is to get the y alone, and it looks like we have to get rid of the 3 and the x somehow. Now for the time being, I'm going to rewrite the 3yx as 3xy. And technically, since it's multiplication, that's the same thing. But now, to get the y alone, I can just divide by 3x to both sides. And thus, y is equal to 2 plus 2x, all divided by 3x. Boom. Your y is by itself. You have your answer. You have your inverse. Done. So again, for this type of problem, start by making sure your 3y minus 2 is not on bottom by multiplying to both sides. Then distribute, and then start solving for y, just like we did here. And if you can do that for this problem, it's a piece of cake. Okay, now there's one more problem I want to show you. And well, there's two ways to do it. The first way is this way. I went ahead and did all the steps for you. You're feel free to look at those steps and figure it out if you want. But some of you are probably looking at all those steps and wondering, ew, 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 ew. All of that work just to get this answer. And you're probably thinking, oh, I'll just take the strike on that one. I'm not even going to touch that. That's just too much work for me. I know some of you are thinking it. I know who you are. Now, that's the first way you can solve this problem, is by trying it this way. But there is a second way. And it's actually much faster. And all it takes is 2 steps. Let me show you. So for the first step, I want you to rewrite this fraction. And specifically, I also want you to write a positive 1 in front of that x. So now that we've rewritten it, here's the first step. I want you to circle the upper left number and then circle the lower right number. And make sure you include the minus sign with that 4 so it looks like a negative 4. So look at the upper right, look at the lower left, and the first thing I want you to do is change the signs so that the 1 becomes negative, the 4 becomes positive. That is the first step. Now for the second step. Well, you've just changed that 1 to a negative, and you just changed that 4 to a positive. But we're still going to look at those two numbers. Now for step 2, what I want you to do is take those two numbers, switch places with them. So instead of a negative 1, you now have a positive 4 on top. Instead of a plus 4 on bottom, you now have a minus 1. And once you have that, this should be your inverse answer. And hey, check this out. 4x minus 5 all over 3x minus 1. Look at the previous slide. 4x minus 5, 3x minus 1. You get the same answer the long way, you get the same answer the short way. Booyah! So, you got two ways to do it. You can do the long way if you choose, or you can try the short, quick, fast, I'm done way. You pick, you decide. But let's do one more of these just so you get the feel. So again, you have a fraction where you have an x on top and x on bottom, and you need to find the inverse. You can do the long way if you want, where you take the y, make them switch places, get the y alone, blah, 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 blah. But if you do the short way, this is what you're going to do. First step, you're going to have negative x plus 4 all over negative 2x plus 3. And let's squeeze in a 1 in that upper left corner, so it's actually negative 1. So take a look at your upper left corner and then your lower right corner. First thing you're going to do, change the sign. So now that's a positive 1, and now this is a negative 3. That's step 1. Now let's do step 2. So now we just have positive 1x plus 4, and then we have negative 2x, and that is now a minus 3, not a plus 3. So again, upper left corner, lower right corner. And now for step 2. Make those two numbers switch places. So instead of a positive 1, you now have a negative 3 on top. And instead of a negative 3 on bottom, you now have a positive 1. And once you've done that, you have your inverse. And you're done. And that is 90% of today's lesson in a nutshell. And now, the last 10%, real quick, real easy. So, you guys are familiar with the vertical line test. Basically, you take a vertical line, make it run through a graph, and it will tell you if it's a function or not. But believe it or not, there is not only a vertical line test, but there is also a horizontal line test. And basically, it's when you take a horizontal line, run it through your graph, and what it does, it will tell you if a certain function will have an inverse or not. And most of the times, when you use the horizontal line test, you will have an inverse. There are a couple cases where you will not have an inverse, and I will show you those examples on the last slide. So, let's say you have the function x squared plus 4x. Well, I can tell you right now, the fact that you have an x squared is going to tell you that your graph is going to have a parabola, basically the U-shaped curve. Now, if you were to do the HLT or horizontal line test and run that horizontal line through your U-shaped curve, you could see right away that that graph would fail, which means it would have no inverse. And another example is the absolute value bars, or the absolute value function of x. If you remember from Algebra 2, this graph is always the V-shaped curve, basically the V-shaped graph. Now, what if you use the horizontal line test on this function? Take a horizontal line, move it through the graph. You would also tell that this graph would fail, and thus it would have no inverse. These are the two most common cases where it will not be an inverse. Most other cases, you would have an inverse. Like, for example, x cubed. X cubed's graph looks like this. And if you were to take a horizontal line through that graph, it would pass, which means it would have an inverse. So basically, all I want you to remember for right now, if you see an x squared, you will know it will fail. If you see absolute value, you know it would fail, and thus it would not have an inverse. As long as you remember those two graphs and those two functions, the rest is easy. And with that, you officially know everything you need to know to tackle the online homework for 3.7, inverses of functions. See you later, class, and have a good day.